Greetings. This is Eric Falkenstein. I just wanted to give a little explainer with this Python program that I posted up with today's blog post, June 12th. So it's called AMM with whitelisted ARBs. It goes over a mechanism to reduce the LP's impermanent loss. So how that works is explained in words, and I also present a nice little program where you can run the simulation that I use to generate the graphs in that post. I prefer Gauss, but that's me. I'm old school. This works fine too. It's slower, but I don't use Python a lot, so maybe someone can get it to work faster. But anyway, so the basic idea is, well, you can run this. It runs it over 100,000 simulations with 1,000 steps. That's 15 minutes. So kind of a long time. So if you add to the simulations, I found that going to 1,000,000 doesn't really help, but you might want to add more steps, because if that was a year with 80% vol, that would only be 3 trades a day. But anyway, it's the basic mechanism is explained there. It's a very simple model because there's no retail trades. There's one LP and one ARB, but this gets at the gist of what drives, like, how it works. And it's driven really off of 3 things. One is, because we give the ARB a fee advantage. He pays 0 fee. It's fair to assume that the ARB collective is going to dominate arbitrage trading. And so they're going to mirror the LP changes. And so that basic idea is here. So if we look at changes, noise traders on average have 0 net demand. So we can assume that every change in the pool on average is going to be mirrored by changes in the ARB. So if the pool gains, Y of USD, the ARB is going to lose Y of USD. And that logic goes through. The LP is levered. So, when the pool changes and the pool adds YUSD, he's got debt, but the debt's not going to change, at least not at first. And then so his net USD position will change. And that's implicit in these simulations. And so what we can see is, if the next mechanism is basically collateral swapping. And that's explained in this little spreadsheet. I explained it in the blog post, and it's implicit in the program. But here we see that, okay, if they start out, the LP's levered 5-to-1, the ARB account's got money in there. The LP actually has debt, but the ARB initially does not. But he has a margin account, so he can have negative values. The LP, he's defaulting if he gets negative values. But this is where the collateral swapping comes in. It really helps the LP avoid this problem. And so in this example here, the price of ETH fell 36%. The LP doesn't have any more USD left, which is like reaching the end of a V3 bin, and you have no other ones left. So the AMM is not bankrupt, but it's not functional anymore. We need more USD. This wouldn't happen in real life, right? This is an extreme example. But so to rectify the imbalance, to get ETH back in there, well, remember, the ARB has a mirror image. So, the ARB is got negative ETH. He's missing, he needs 14 ETH to get back to even amounts of ETH and USD. Whereas the LP, he's got like 11, all he has is ETH, so he's got, 11.25 extra ETH. So what do? We transfer, basically, we transfer ETH to the ARB and USD from the ARB to the LP. And for the ARB, it's pretty straightforward. You just add it to his ETH and USD accounts. For the LP, we basically subtract it from their debt. So to take out 11 ETH, we basically add that to his debt. And to give him the USD, we subtract that from his USD debt. So that's one of the mechanisms going on. And the final mechanism is the profit tax, and the profit is, taken. These would be hit like if certain milestones are hit. So like if the imbalance ever becomes greater than X, you instantiate this, the profit tax, and you also instantiate the collateral change at the same time, and also whenever somebody wants to withdraw. So here, I should mention, after the collateral change, the account's values don't change. All it's doing is trying to keep things in balance more so that the capital allocation is easier, the amount of trades they have to do off contract are minimized, etc. So the transfer doesn't change the value of the ARB or the ETH accounts or the LP accounts. But the profit is just basically, well, he started with $2,000 worth of value and he ended with $5,640. So start value of 2,000. Well, that means he made 3,640. But we want to abstract from the change caused by his initial ETH, because that would just add noise to the ARB's profit if we assume ETH changes are random. So we'll assume he hedges it, and we won't count that in the profit that we tax him. So in this case, the profit would be 4,000, and so we take 90% of that and throw it over to, like, in the fees income for the LP, and then 10% would, well, the ARB would just keep. So if you run the Python program, you'll generate this set of percentiles, which is 100 by 10 matrix. And so if you run through the, let's see here, the simulation first, I have all these parameters, so you can change the parameters and see how they work. It's all based off, every simulation generates, I have 1,000 steps, so generates 1,000 returns using log normal returns, consistent with the 80% vol for the whole period. And given AMM logic, given changes in price, random changes in price, we know it'll dictate what the random changes in the ETH and USD are in the pool. And then you can go through the logic of the collateral transfers and the profit sharing and see how they affect at the end of the day, what happens to the LP and the ETHs and the ARBs, values. So, we log the ending price of the simulation. We log the IL for fun, and then we log the LP's net ETH position, his net USD position, the net amount of tax or like fees he would receive from the ARB, and then we also the net value of the ARB's ETH and USD position, and then we throw those into a matrix called sim output. I have 100,000 simulations here, so we have 100,000 rows, and then what you do is you sort that by the price, which is that first column, and once you sort that by the price, put it into 100 bins, and you get percentiles for all these things, like, well, the value of the LP and the value of this, and so it'll kick it out, and it'll kick it into a spreadsheet, an XLS spreadsheet here, and you can see it's got headers on it, but it doesn't have anything else. I said, I'm not really good with Python, so I don't know how to, well, I know how to write it to one, but it's really slow if I write it to an existing Excel sheet. So you can just take this output here and then paste it into the spreadsheet that's also on the blog post and the bottom of this YouTube video. And you can see that, given the assumptions, the impermanent loss is 13,700. I also calculate it via the gamma or lever, which is kind of a instantaneous measure, and you can also see that the log returns do have a standard deviation of 80% as expected. That's a good check. You can also check to make sure, is the amount of ETH in the contract constant, because there should be no ETH and USD leaking out or in, and it's constant over all these periods, which is good because it just gives you a sense that we're not losing anything. As mentioned, the IL and the gamma, two ways, they have the same expected value, but obviously the gamma one is kind of like you're delta hedging all the time, so it's less risky, so it has, the reason why people hedge, why option market maker hedges is not because it changes the expected value, it changes the capital they need, which does lower their costs. but it doesn't change the expected return. And that's reflected in the, if you look at the what we're doing here, well, if you take the unlevered V2 position, the levered one can go negative. And the price has to move a lot, but it can go negative if you just lever it and don't touch it. If you lever it and you have this collateral swapping, you can change this curved line, this green line, into this black line, which is smoother. They have the same expected value, just like those gammas had. The gamma had the same expected value as that, U-shaped impermanent loss. And then once you add back in the fees, then you get this bump up, and you recapture 90% of the impermanent loss. You still lose money, but get you a long way there. Like I said, if you add new noise traders, you should be able to make money. At the end of the day, if you don't have noise traders, no LP is going to make money. So it goes through those, and if that works, if you have any questions or comments, find any errors, let me know. Anyway, so hope you like it. Thanks.